Good morning, student. I am KHAIRNAR PGT Physics from Jawahar Navodaya Vidyalaya, Shegaon. Dear student, today from the chapter of laws of motion, we are going to start the topic that is circular motion of a car on a level road and banking off. So these you can see the two topics we have to discuss here, and I hope all of you will enjoy this topic while discussing. Please, your cooperation is needed for this one. So let us start our topic. So on a circular motion of a car on a level road. So itself it is here given that on the level road. So what is meant by a level road? Level road means simply a plain straight road, you can say. It is not raised at some height from any one side like that one. Okay, so a level road, a circular motion of a car on a level road. When a car negotiates a curve level road, the force of friction between the road and the tires provides the centripetal force required to keep the car in a circular motion or circular motion around the curved path. You know, students, whenever we are having any object in a circular motion, then the centripetal force, very important, centripetal force is required to keep the car in motion. So what is in by centripetal force? Centripetal force means nothing but the force which is acting toward the center of that circular path. Suppose if you have tied a stone with a string, and if you are wheel that one in a circular path, okay, moved in this one, then you can say a force which is acting toward the center is called as centripetal force. Centripetal force. Another force is also there which exists at the same time. That is called the centrifugal force. Centrifugal force means what? The force which is acting away from the center. And centripetal force is nothing but the center seeking force. The force which is acting toward the center. Okay, by means of which you will get provided the circular motion, you can say here. Okay, so this is the important thing which is related with the centripetal force and centrifugal force. So now what we have to discuss here, suppose now in the given figure, consider a car of weight mass mg going around a circular level road of radius r with constant speed v. While taking turn, the tires of the car tends to leave the road and go away from the center of the curve. The forces of friction F1 and F2 acts inward at the inner and the outer tires respectively. So dear student, here we have considered that the car is taking or going around a circular level road. Circular level road. But first of all, we will consider the case what happens when the car is moving on a level road. This is the circular level road, you can say. Okay, so let us proceed for that one first. So let us consider a level road, you can say, and the car is stationary. Car is stationary. Then, if suppose this is the level road, and here you are having the car, this is the center of gravity, where the weight of the car is acting in W is equal to M into G. That is in the downward direction. Okay, so this is yours, you can say, the inner tire and the outer tire here. So when the car is stationary, or you can say at rest, then this weight of the car is divided equally on these tires. That is, on this tire the weight will be 1/2 of mg and this tire also 1/2 of mg. These two will be divided here. So whenever the car is standing on the level road, that time you can say, since the equal weight is going to be shared by these two tires, therefore we can say that there is no possibility that the any one tire which is having the greater load on it. Okay, so now the next thing, if suppose I will make a car stationary, again the stationary on this type of road, that is you can say inclined road. Inclined road. Suppose inclined at an angle theta, you can say here. Okay, so here the car which is on this inclined road, so its weight will act in a vertically downward direction, just as that of the previous case. So you can see here this distance and this distance. So this distance is smaller, suppose it is L1, and this distance is bigger, that is L2. That means you can say that the load is little bit shifted towards this tire. Or ultimately we can say that this tire is facing the lot of, that means it is facing the load than that of this tire. Suppose this is the inner tire and this one is the outer tire. So the outer tire is having a little bit less load than that of the inner one. So I think this is not a favorable condition for us. Okay, so these two things you have to keep it in mind, that what happens when the car is rest on a level road and what happens when the car is stationary on an inclined road. So this is not the that means you can say the actual case in our day-to-day life, but this is the actual case. You can say whenever the car is in the, you can say the garage or somewhere it is standing, then we are always prefer this type of situation, so that no tire of this car should have the excess load. Now next one we will discuss here, when the car is moving. Now see here, whenever the car is moving, then that time when it take the turn on a level road, when the car take the turns on level road, then what happens? You see here basic things are here. The load, the car is on a level road and want to take the turn in this side like this. So suppose initially this is the direction of the car which is moving in this direction, and suppose if it want to move in this direction, suppose this is the point C is here. So actually this car wants to move in this particular direction. Suppose this B point is here, but you have taken the turn by using the steering, you can say. So the force which is called as the centrifugal force, this will act in this direction. Because actually the car wants to go to this point B, but since you have taken the turn, so the force will act on the car which will be centrifugal force. Centrifugal force. But if the car is on the road, you can say, if the car is on the road, then that time that centripetal force will be balanced by the centrifugal force. Centrifugal force. That means the car will not skid out of the track, you can say. So in this case, so in this particular case, when the car is taking the turn, that time, if it is on the level ground, okay. So if the car is moving in this particular direction, so just I told you about this centrifugal force. So the centrifugal force will act in this particular direction. And this is nothing but the weight of the car. That is nothing but mg. So if you take the resultant of this one, so it will pass. So from this figure, what do you observe? You observe that the point is shifted to this particular point. Suppose the point is O here. That means when the car was standing on a level road, that time the point was at the middle. You can see. Okay, like this. This was at the middle, but now since it is taking the turn here, so the point has shifted to this one particular side. Or you can say that this point has shifted towards this outer tire. So it means that whenever the car takes the turn, so that time the excess load or the more load will be on this tire than that of this tire. I think you have got this concept now. When the car is taking the turn on the level road, then that time this outer road, outer you can say this tire will have to face the more load than that of the inner. That means what are the chances there? The chances are the wear and tear of this tire will be more as compared of this one. Or we can say that the frictional force between these two tires which are going to take place, the frictional force will be more here than that of the frictional force at this particular point. So now if such a situation is there, we are dealing with the road here. But what about the railway track? If the railway track is there, level 1, and you want to take the turn, then ultimately you can say the outer rail, here the rail will be like this. Then this outer rail will have to suffer the more friction than that of the inner rail. So if the outer rail is having more friction, then ultimately we can say we have to change the outer rail frequently. But that is not that you can say that is not a simple task. So we have made some another arrangement. So what is that arrangement we have made here? When you want to take the turn on the level road, then that time the outer rail should not suffer the more friction, or the outer tire of this car should not suffer the more friction. So for that one, we have made an arrangement which is called as a banking of road. See here what happens in case of banking of road. Suppose here, what is banking of road? Banking of road means outer edge. This is the outer edge. Will be raised. Outer edge will be raised with certain height or with certain angle theta with the inner edge. So that is called as the banking of road. Now what happens here? When the car is taking the turn on this track, you can say. Okay, so just I told you about the centripetal force and centrifugal force. No doubt the centripetal force will try to act toward the center of the circular track, of the radius of the circular track, but at the same time the centrifugal force will be in this particular direction. So suppose the centrifugal force is in this particular direction and the weight of the car is in this direction. So if you take the resultant of these two, then this is the resultant of this force. You can say the centrifugal force which is acting in this particular direction. So you can see now this point which was shifted while taking the turn on the level road, it is now at the middle of this one. If it is shifted at the middle, this weight is equal to m into g. That means this tire, inner tire, and outer tire will now have the same weight or equal weight even though the car is taking the turn. And this is the important thing which you have done simply by raising the outer edge. Raising the outer edge. So we have solved the problem simply by raising the outer edge, so that there is no question of now the more friction of the outer tire than that of the inner one. So these things is very important now, and we have to discuss about we can say about the derivation of banking off-road now. So what is banking off-road here? Now first of all, we'll see in case of the level road what should be the maximum velocity in case of this the level road. You see in this figure, this is nothing but your level road, in which this tire, first tire, suppose you can say, and is the second tire, having the force of friction F1 and F2, and its direction is toward the center of the circular track, and the distance of this car from the center of gravity, you can say, that is nothing but the R. And R1 and R2 are the normal reaction of this tire. Okay. Now you see here, we have to find out the relation now. So what is the relation you will get in this particular case? So the resultant R1 plus R2 will be balanced by this weight mg. And the force of friction F1, where the normal reaction is R1 of this tire, first tire, and R2 is the normal reaction of the second tire, and F2 is the force of friction whose direction is in this particular direction or toward the center of the circular track of radius R, you can say. So that are the F1 and F2 are the frictional forces. So coming to the next one, if R1 and R2 are the reactions, if here R1 and R2 are the reactions of the ground, just we have seen, R1 and R2 are the reaction of the ground at the inner and outer, then outer, you can say inner and outer tire, then F1 is equal to mu into R1. So here this mu is called as, you can say, the coefficient of friction. Mu is called coefficient of friction between the tires and the road. Remember here, general formula you know, F is equal to mu into R. Okay. So this mu is called coefficient of friction between the tires and the road. Now similarly, F2 is equal to mu into R2. So as the total normal reaction balances the weight, I told you this R1 and R2, R1 plus R2, which are going to balance the total weight mg of the car. Okay. Total weight mg of the car, then I can write here R1 plus R2 is equal to mg. Very simple. Since the total normal reaction are going to be balance the weight of the car, you can say. So R1 plus R2 is equal to mg here. So the total force of friction. Now we'll come to the part of this total force of friction. This is the force of friction due to the, you can say, the inner tire, and this is the force of friction due to the outer tire, you can say. Therefore, the total force of friction, you will get F1 plus F2, which is equal to, putting the value of this F1 and F2, mu into R1 plus mu into R2. So you will get mu into R1 plus R2. So this is the value of the total force of friction. So dear student, for the car now to stay on the road, the maximum force of friction must be equal or greater than the centripetal force. You see what I told you, whenever the car want to take the turn here on the circular track having the radius R, you can say, then if that vehicle want to take the turn safely, then that time the maximum force of friction must be equal or greater than equal to the centripetal force. And centripetal force is nothing but what? The force which are acting towards the center. You can say towards the center of the circular track. So from this one, I can write here R1 and R1 plus R2 is equal to mg. This one is equation. So I'll put the value in this equation. So I can write here F1 plus F2. This one will become now since R1 plus R2 is equal to mg from this equation, put the value in this equation, you will get F1 plus F2 is equal to mu into mg. And as you want the car to stay on the road, the maximum force of friction must be equal to or greater than the centripetal force. So what is the formula for the centripetal force? Centripetal force is nothing but mv square upon r. So that's why I am written here mu into mg. The net force of friction. The net force of friction mu into mg is greater than or equal to mv square upon r. And by simplifying this one, I will get here that is mu into mg is greater than or equal to mv square upon r, cancelling this m from both the side. So mu is greater than or equal to v square upon r, or I can write v square is less than or equal to mu and mu into, right here g is there, mu into rg, or v square is equal to mu rg. So from this one, I have written the value of the velocity, that is v square is equal to mu into rg here. So the next point, the maximum speed. Now just I told you, when you want to take the turn, that time if you want to take the turn with the maximum speed, then you should have some condition there. So what is that condition? The condition is, if you want to take the maximum speed with which the car can take the safe turn, very important, safe turn, then you will get V max or maximum velocity is equal to square root of mu into rg. So dear student, from this formula you can easily observe that the maximum velocity with which the car will skid, or if the speed exceeds of this velocity, maximum velocity, suppose the speed exceeds this velocity, then the car will skid and go off the road in a circle of radius greater than r. That means ultimately we can say that if the car exceeds this particular velocity, then it will skid away and it will go out of the track. Why this is so? This is because the maximum available friction. Actually, I told you the force of friction between the tire while taking the turn on the circular track. So that is insufficient now. Insufficient to provide the necessary centripetal force. So the important condition is that when the object or the car want to take the turn on a circular track, or if the car want to take to move on a circular track, then the centripetal force must be balanced, or the necessary centripetal force, if it is balanced, then we can say the car will easily take the turn there. But that is having a certain limit. What is that limit? What is that limit? That limit is nothing but this one. So the maximum velocity should be mu into square root of mu into rg. So ultimately, if the values are given to you, you can calculate the maximum velocity from this formula. Okay. So if the velocity is maximum, then there is a chances for the car to skid and go off the road. Okay. You go off the road means what? It will leave the track. It will leave this particular track and it will go to the out of this one, having the greater radius. That is the meaning of this one, having the radius greater than r. Actually, r is the radius of this particular track. So if it is going away from this one, that means that car is moving to a particular, you can say the radius which is greater than this r. So the maximum safe speed Vmax depends on, now see from this formula. From this formula, you can easily see that the maximum speed depends on which factor? Depends on coefficient of friction mu, radius of the circular track, and g, you can say. So especially this is the constant one, 9.8. meter per second square. So mu into r, that means mu and r, these are the two factors on which this velocity, maximum velocity, depends. Okay, so this is what about we have seen on the level road. If the car is taking the turn on the level road, then its maximum velocity should not exceed of this particular value. But now the condition is that when the car is moving with a speed greater than this one, but still we want to take the safe turn, then what we have to do? Just I have told you in the just previous you can say the few minutes before, that when the car want to take the turn, then that time what should be the value? The condition is that it should be a bank. So what is meant by banking off road now? What is meant by banking off road? So banking off road, the system of raising the outer edge, of the road above the inner edge. That means if you are having this road, level road, you can say, then this is the outer edge and this is the inner edge. So this outer edge should be raised with some height, with the inner edge, with some angle theta. So the angle through which the outer edge of the curved road is raised above the inner edge is called angle of banking. This angle theta is called angle of banking. So I hope you might have got the idea about this benefit of this banking off road. What is the need of the banking off road? So we want to take the safe turn, but we want the velocity should be more than that of the level road while it was skidding up the road while taking the turn on the, you can see, the level curved road. Okay, so we'll proceed for the derivation for this banking off road now. Okay. So you see here in this figure. So in this figure, the car of weight mg is nothing but the weight of the car. The car of weight mg is here going along the curved path. It is moving along the, you can say, curved path of radius r with a speed v on road banked at an angle theta. So this angle theta is called angle of banking. Angle of banking. The forces acting on the vehicle are very important, students. The forces which are going to be act on the vehicles are: the first one, its own weight mg, which is in the vertically downward direction. Second one, the normal reaction r of the road acting at an angle theta with the vertical. See, this angle is theta with the vertical. Now you will get confused here a little bit. Sir, this angle is theta, angle of banking, you say. Okay. So how this angle will be theta? So let us take this point. Suppose this point is O point. I will take this point for the understanding the geometry here, like this. This is here. So I will shift this point here. This is nothing but mg. This one is r cos theta. Okay. Then this is the normal reaction r, which is this r is divided into two rectangular component. So we have to see about this one, how this r cos theta and this one is r sin theta. So this angle is theta. So ultimately this angle will be theta, alternate interior angle. So this one is 90 degree. So this will be 90 minus theta. Again, this is 90. So I can say that this angle is theta. And this will be 90 minus theta. So this angle theta will be equal to this angle theta, or this angle theta will be equal to this angle theta. Got it? I think all of you understood this now from this figure. So this angle is theta. Now resolve this one r. What is this? R is the normal reaction of the rod. R is the normal reaction of the rod acting at an angle theta with the vertical. So resolving this one, we get this component is r cos theta and here r sin theta. As this angle is 90 minus theta, so we can write here r into cos 90 minus theta is sin theta. So this will be r sin theta. Now coming to the part of the force of friction, very important, force of friction. So these tires now, these tires while taking the turn on this curved path, not facing the load, excess load on any one of the tire. Just before one I have explained you. So that is the safest condition here, or the safe point as far as concerned, that when the car is taking the turn on the curve, you can say bank road. So this is nothing but the bank road, which is banked with an angle theta here. Okay, so the frictional force now, which is acting in this particular direction F. So I have drawn this figure. Now instead of here, let us draw here. So this force of friction, the same I will continue. This is nothing but here F, which I have shown here. Okay, resolve this one into two components. One component is in this direction and another component is in this direction. So this angle is theta. So this angle is theta, vertically opposite angle. So we can say that this component is F cos theta and this will be F sin theta. So dear student, this figure, explanation of this figure, I think you understood from this figure. Okay, so here the force of friction acting downward along the inclined plane. And I have resolved that force of friction into two components, F cos theta and F sin theta. Now what is my first target here? Now I have to go for the you can say the we have to take all the forces or equating all the forces here. What are the types of forces are here? You can say here the r cos theta, r sin theta, then mg, then F cos theta, F sin theta. I have to equate all these forces. And after equating, what I will get, that is my next task. Okay, so I am going to equate about these forces now. After equating this one, here, after equating the forces, this force, r cos theta plus F cos theta is mu square upon r. Let me explain you about this one in the previous one. Okay. So I will write here itself. So this r cos theta in the upward direction, this one, okay, and this mg and F cos theta. So this will be balanced by this one, and again the force of friction F sin theta is there. So I can write here r cos theta is equal to mg plus F sin theta. And I will shift this term to this side. So I will get r cos theta minus F sin theta is equal to mg. Suppose this is equation number 1. Then I will equate the other forces now. See, r sin theta and F cos theta, they are toward the center, you can say, and they will be balanced by the centripetal force. So I can write here r sin theta plus F cos theta is equal to mv square upon r, which is the formula for the centripetal force. Suppose this is equation number 2. Now I will divide 2 by 1. I will divide 2 by 1. So once I will divide, then I will get here r sin theta plus F cos theta upon r cos theta minus F sin theta, which is equal to mv square upon r divided by mg. So simplifying this one, I will get cancel this mg. I can write v square upon rg. So again, what I will do here, I will divide this term by r cos theta. Okay, so dividing this one r cos theta, what I will write here, that r sin theta plus f cos theta divided by r cos theta. Remember, this r cos theta is divided by this total one. Okay, divided by this one again, r cos theta minus f sin theta divided by r cos theta, which is equal to v square upon rg. So now, dear student, I can write here the further steps. That is r sin theta upon this r cos theta. I will give to both the terms, r cos theta plus f cos theta divided by r cos theta divided by r cos theta divided by r cos theta minus f sin theta divided by r cos theta equal to v square upon rg. I think all of you are understanding these steps. Slowly, step by step, I am proceeding here and clearing each and every step. So now here I will take the ratio of sin upon cos is nothing but tan, and this cancelling this cos, again this cancelling this r cos theta. Okay, here again r. So I can write here by simplifying the above one, I will get the modified equation as tan theta. You can say r sin theta upon r cos theta, that is tan theta plus f upon r divided by 1 minus f upon r tan theta, which is equal to v square upon rg. Now, dear student, you know the formula for the coefficient of friction, that is mu is equal to f upon r, where mu is called as the coefficient of friction. So putting this value of mu in this formula, I can write tan theta plus mu divided by 1 minus mu tan theta equal to v square upon rg. Or if I want to find the value of v, then simply I will take this term to this side. Okay, then v square will be equal to, I will write here, v square is equal to rg into mu plus tan theta divided by 1 minus mu tan theta. And if you want to take the value of simply the velocity, then take the square root on both sides. So you will get v is equal to square root of rg into mu plus tan theta divided by 1 minus mu tan theta. This is the very important relation when the car is taking the turn on the bank road. Here the banking of road we have done, and on that one the car is going to take the turn. So if you will neglect the frictional force, coefficient of friction, suppose mu is equal to 0, this is the special case. If mu is equal to 0, then this equation will take the new form, that is nothing but, let me write it here. So you can easily observe what will be the new form here. Then the new form will be v is equal to square root of rg tan theta. Why? Because here mu is equal to, suppose 0 here, then 0 plus tan theta, and 1 minus mu is 0. So 1 minus 0 is 1. So tan theta divided by 1 is 1. So we can write v is equal to rg tan theta. Okay. But when mu is equal to 0 here. So ultimately we can say that the velocity is now dependent on this radius r of the circular track and the theta angle theta. So I can calculate the value of theta from this one as v square upon rg is equal to tan theta, or theta is equal to tan inverse of V square upon RG. So I can get easily the value of the tan theta. Now dear student, sometimes they are asking in the examination, if the banking of RAOD, that is tan theta, if you will get 1 by 7, then what is the meaning of this one? That means when you have raised this outer edge with some angle theta, then this will be 7 and this will be 1, like this. Because if suppose this is tan theta, then I can tan theta is equal to 1 by 7. So if 7 meter is here, then 1 meter will be like this. Okay, that is the meaning of this tan of 1 by 7. That is nothing but the ratio here. So you can explain this one in terms of the banking of RAOD also. So I hope from all this derivation from this particular diagram, or when the car is moving on a bank road in a circular track, then that time we got the relation that is V is equal to square root of RG tan theta. Okay, now the same thing we have derived in this particular slide also. Just whatever I explain you by solving each and every step, same thing is here. Next one, we proceed for the numerical. So by solving the numerical, you have to first of all read the problem very carefully. And at the same time, you have to write the given things. Or you can say in the solution now, first of all, you have to write given thing. So what are the given things here? So given things, the circular track, first of all, read the problem very carefully. A circular race track of radius 300 meter. That means R is given 300 meter. Is banked at an angle of, how much is the angle here? 15 degree. That means theta is given 15 degree. If the coefficient of friction, that means mu, is given to you between the wheels of the race car and the road. No doubt the coefficient of friction takes between the wheels of that particular car and the road itself. So that is 0.2. These three things are given to you, and they have asked you to find or what is the optimum speed of the race car to avoid wear and tear. Wear and tear, that means you should not be having a more friction there. Okay, so what is the optimum speed? Just now we have derived the formula, that is V naught is equal to, or V is equal to square root of RG tan theta. So dear student, put the value in this formula, you will get the optimum speed. V naught is equal to, what is the R here? 300 into, what is G? 9.8 meter per second square into tan of 15 degree. Now you should know how to find the tan 15 by using the log table. So from the log table, I can find out the value of tan 15 degree is equal to 0.2679. The value of this one is 2679. Tan 15 is 2679. So put this value here. So I get V naught is equal to square root of 300 into 9.8 into 0.2679, and by calculating this one, you will get the optimum speed. It will be 28.1 meter per second. So this is the value of, you can say, the optimum speed when the radius is given 300 meter and the theta is given here. The theta is given 15 degree. Radius is given, you can say, 300 meter, and coefficient of friction is given 0.2. Understood? Now the next point, B. The maximum, what is the maximum possible speed to avoid slipping? That means the car should take the turn safely on this curved road which is banked. So we are having the formula. That formula is Vmax is equal to square root of Rg into mu plus tan theta upon 1 minus mu tan theta. Okay, So by putting the value of all these things here, Vmax or the maximum speed will be equal to V is equal to square root of this 300 into 9.8 into bracket 0.2 plus tan 15. Already we are having the value of 0.2679 divided by 1 minus 0.2 into 0.2679. So by solving this value, we get the maximum velocity as 38.1 meter per second. Okay, so these are the two values for the optimum speed of the race car to avoid wear and tear, that is 28.1, and the maximum possible speed to avoid the slipping. That means the car should not skid away or should not go out of the track. So this is the limit for this. Remember, 38.1 meter per second is there. So after solving this interesting problem, so some of the problem I have given to you as a homework. So please go through that problem also. So these two problems I have given you as a homework.